Good morning to all of you. Today we are starting a workshop on research methodology tools and techniques that is organized by Department of Computer Science and Engineering, Center of Excellence for IoT and Advanced Computing, IQAC and IIC. Now I would like to invite Dr. Sanjeev Kumar Gupta sir, Dean Academic of Rabindranath Tagore University, for the welcome to our first speaker, that is Dr. Ashish Chandra. Sir, please.
Sir, good morning. Thank you, Rakesh sir. Thank you. Thank you. Sir, good morning, sir.
Very good morning, sir.
Sir, on behalf of RNTU and Research Cell, I welcome you, sir, please. And also welcome to all the participants here. And thank you, Ashish sir, Rakesh sir, that they have organized such a knowledgeable webinar because, sir, we are having around 200 such scholars in our university in the engineering stream. So this topic, research methodology, we are also teaching in the coursework, and theoretically, as you know, that Kothari's book is there, so we are following that book, and other books also they are studying. But sir, today in morning, sir, I was discussing with the Mukesh sir and Rakesh sir कि sir, आपका sir जो experience है, I think sir today we will learn a lot from the industry side.
Yeah.
डेफिनेटली सर एंड मुझे सर इतना अच्छा लगा देखकर कि जो प्रॉब्लम्स हम लोग जनरेट करते हैं पीएचडी के स्कॉलर्स हैं या जो हमारी फैकल्टी मेंबर्स हैं शेयर करते हैं तो मोस्ट ऑफ द प्रॉब्लम्स दे आर बेसिकली बेस्ड ऑन द एल्गोरिदम्स एंड अदर थ्योरेटिकल टॉपिक्स. आज एक ऐसा समय है सर कि आज सर से बात करके और इसको हम शायद थोड़ा सा और आगे भी सर को ले जाएंगे. कुछ ट्रेनिंग्स पे हम लोग बात कर सकते हैं आगे, क्योंकि जिस तरह की रिसर्च प्रॉब्लम सर हमको दे सकते हैं, जिस तरह की प्रॉब्लम्स को लेकर हम लोग आगे बढ़ सकते हैं. सर, इट इज वेरी वेरी ग्रेट. ग्रेट सर. सो आई वेलकम यू ऑल अगेन. सर का मैंने एआई का देखा और रोबोटिक्स का भी देखा. So these topics are basically common for all the research scholars, not only in the electronics and communication, computer science, IT, in mechanical also, in electrical also. So we are having the PhD scholars in all these streams. So definitely, sir, आज के लेक्चर के बाद in future we will discuss more. और कुछ ऐसी प्रॉब्लम्स हम लोग भी काम करना चाहेंगे जो आपकी तरफ से हमको मिले. And I hope that we will go for the long association.
Yeah, surely.
Yes, sir. We will discuss after this webinar. So, Rakesh sir, over to you.
Okay, thank you, sir.
आज सुनूंगा and I think you can start. आज से PhD scholars ही हैं सर यहाँ पर और धीरे धीरे वो ज्वाइन भी करेंगे.
Okay. Now I'm seeing that there are 13 attendees.
Thank you.
Okay, sir. Thank you, sir. Thanks a lot. Now I'll introduce Dr. Ashish Chandra. Dr. Ashish is a great personality. Great personality means that he is collaboration with the teaching and as the sir said, that the industry also. So at present, Dr. Ashish Chandra, that is the Chief Executive Officer in Bronto Byte Analytics, Hyderabad. Sir has great experience in the computing, artificial intelligence, robotics, IoT, and as a teacher and trainer. Sir had done his PhD from the Agra, and that is PhD especially in the artificial intelligence, and the MTech from the Agra. And sir, a lot of experience in the as a professor and now as a chief executive officer, and along with that is in the AI and the machine learning trainers and consultants. So today, now I would like to invite Dr. Ashish Chandra. Sir, please.
Thank you very much, sir. I have a long association with Aisect. I am visiting Aisect. Now it is RNTU. So I am visiting Aisect from last 6-7 years, so maybe from 2012 or 13, and I'm regular there for giving expert lectures. So there is a long association with you, and thanks a lot. So I am starting my lecture. Before starting and sharing the screen, I would like to say that the research is an art as well as a science as well, because already sir has told that, Sanjeev sir, that it needs a lot of algorithms, mathematics, and a lot of technology, computations. So my focus today is basically on this topic only, that how you will be practically implementing a research problem. But I cannot take a specific problem to all of you. You will be, somebody is working in biotechnology, somebody will be working in mechanical problems, somebody will be working in electronics, computer science. So we will take a generalized way of solving a problem, understand how the research should be done, how algorithm or model should be done and developed, and how we can analyze that. So my major focus today will be on data analysis and model development, and how to get the result and develop the results. So there are many tools. You may be knowing that there is MATLAB, Matrix Laboratory, of we call it in the full form, from MathWorks. There is SPSS from IBM. There is other tools also. There are languages also, many languages like Python. But my focus today is on GPL license software, or an language. I will call it as a language as well as a software, because it has both the components, and that software is a simple one single letter, and it is known as R. You will be astonished that there is a only R, which is an ocean for all the researchers, because it is a open source software. So we should prefer open source and GPL license, because when you are doing research, you want to do at your home, and if you are not having license, you will not be able to get the outcomes, because lot of tools and other things are hidden back behind the license. And if you take the free versions, they do not give you the complete exposure or the software usability, and that affects really. So what we have to do, we have to understand how we can solve the problem using open source. I promote mostly open source softwares, because that is good for researchers, students, as well as our academic side and industries also, because these softwares will make a tight bonding between the industry and the, because already the academicians are knowing those things, and we can understand and we can implement those things in our real life problems. So I'm sharing my screen right now, and is my slide visible to all of
Yes,
you?
sir. Yes,
Okay,
sir.
that's nice. So coming to the today's topic, which I proposed, is our language for research, because I told you there are many languages. I like Python also. Python language is a very preferable language in industry, because every company, whether it is IBM, Microsoft, whether it is Google, prefer to develop models and do analysis using Python also. So this tool. But for today's topic, I thought that I can take Python language also for research. But Python is much more towards the industrialization, and it is used by the persons who are in the industries, and they want to develop some larger prospects of things. But on the research part, I think R is much better on data analysis and model development. It is simple and easy also. So Python has a lot of complexity. It needs a hardware base also. So on the contrary part, I thought that R is much more supportive, and I should go on R. So everybody in the participants will be very happy to learn a new language. If they are knowing R, then it is very good. So we will start R. for the new persons who are not knowing what is R. So I will tell you that R is one of the most powerful platforms. It is not that you think that R is a simple software. It is has a plethora of libraries. I think that there are thousands of libraries which are useful for any type of works. So if you are from mechanical, or if you are from electronics, or you are in the computer science department, everybody has its own library tools and you can utilize it for your purpose. But today I am much more focused on the PhD scholars who are developing some models analysis and then predicting the results and publishing it to get the better results than the previous one. So what they need is a platform where they can just input the data, develop the models using the built-in library functions and get the outcomes. So R can be used for this purpose, and I am totally focusing on today's topic in the data scientist world, not on the engineering aspects. I am focusing on data scientists in the world, because PhD scholars are data scientists, and they anyhow have to analyze data and develop models to predict or classify. So both aspects are dealt with R, and it is why we use R for research. So R is a very good platform for starting this complete today's session. I will be assuming that there is no experience with R. You are not having any experience. I'm not able to know whether you are having experience or not. So kindly ask and tell me whether they are having experience with R, and it will helpful for me to take on that part. Anybody who is knowing R. So that can be asked in chat room. So my goal is that to make you comfortable enough to start using R. So I want not to give a complete big lecture on this thing that it is this thing and go out. But I want to show you some running examples also. So we will deal with some basic examples also. My expectation is that once you have achieved, I have delivered, you use this R and use as much as for you, for your betterment, for your solving problems in the PhD PhD domain, wherever you are doing it. So I already told you that today's focus is on data scientist world, because this is very important. I already told you there are plethora of libraries available. I am already telling you that it is a state of art. R is a state of art for academicians, because my focus today is not the industry part, because already sir has told that all the attendees or the participants are from PhD. So my focus is that how R can be used for visualization and model development. So this is my total focus. Yeah, R is available and it is free language. I already told you, and it is much better than SPSS and Excel and all those things. So can we start now, and we will go further inside R.
Yes.
So first, I will tell you that this is a free. You can see on the slide also. This is a free software. R has over 4,000 packages, and every year they are adding out and adding out. And it is very easy to install also. And I already told you that it is free. Free means GPL you can use for commercial purpose also. So, but really academicians are using, and you can see the betterment in the futures also. Yeah, R is a computer language. I already told you it is. I am talking it as a language as well as a software, ID software, because it is having both the parts. It is not that you have to write long scripts and then run it on a particular compiler, but rather it has its own ID, and I will talk it about in the coming session, in the coming slides. So R is basically a computer language, and you can write the scripts and store it in your computer and evaluate it as per requirements. So that is the major part of R. I already told you that R does not mean that you have to write only the codes and it will not give you any graphical representation. It has all the power of representing and the graphs also. And you can do this exploration and development in the REPL environment if you wish. So where this R came from, so that is a very important. All the softwares that are developed in the computer domains are always coming from the academics world. So I would say that R was also developed from the academics, and R was developed in the University of Auckland, that is in New Zealand, and it started in 1993 with the name of S program, S language. It was first S, then it has become R. So I don't know why they have changed the letters, but that was the starting. The owners or the developers may know what was the story behind it. But this version has developed lot and lot and lot and lot. The core group has made this language a huge platform, and now we can do several works on it. So how does R runs? R runs by packages. So everything in R is done by packages. If you see that if you want to do any machine learning or any deep learning or any data analysis, because research is like using the data analysis and model development. That is also the topic of the session. So we need it in a very important way. I told you that I will be going in fast way to the programming part only, but installation is what very more important. So R, you have to install two parts. One is the language and another is R Studio. R Studio is the IDE. IDE means integrated development environment. So you can code and install all the libraries or the packages from the R, and R Studio is the platform which make you very easy to manage everything visually. So I like both the things, and I will show you when I will be doing practical outputs and I will be going out. So first of all, we have to get it. So R you can download from Google just going to the rproject.org. This is the link of the site which I am showing you. And if you want R Studio, then you can go for rstudio.com and download it. First and foremost, you have to install R, then R Studio. Both are separate entity. You don't think that R is same, and if you install R, then R Studio is also installed. No, not like that. R is separate and R Studio is separate. So what you have to do, first install R and then move towards the R Studio. This is the procedure to go. And if you want to know much more about how the installation is and how you can go out, you can go to the R homepage. So this is our home page, and you can see there is written what is R, all the things and everything you are getting, and you will be getting this download R. You can go and whatever version, or it suppose all the types of operating system like Unix platform, Windows and Mac OS. So it's not that if you are on the Linux platform or a Unix platform you cannot use. If you are on Windows also you can use it. And there are versions which is always going on and going on. So choose the mirror from where you can download. This is going to choose your server, which is the most nearest one, you choose that. So that is the way actually it happens. And go for the base level. So you can download it. That I am choosing for R for Windows. Choose the base level. It will give you the exe file, and you can download this exe file, whatever version at your time is, and that you will be supporting, you will get it. It is available in 32-bit as well as 64-bit. But now most of the computer is having 64-bit. So you can choose, but you can go for 32-bit also. It does not make, and it is not very bulky. It is only 37 MB when I was having this presentation, but now it's little bit higher on the sides of the packages. And just follow the instructions as you install other softwares. And once you have installed your R is ready. So you are ready with R. And when you are going for R Studio, you have to go to this site. I already told you. So when you install the R Studio, you will get this type of environment. Means that R and R Studio will be interlinked with each other. R is the compiler language. Whatever is written here in the language, you will get from the R. And whatever you want to do visually, you will be getting from R Studio. So, but you need not to do anything. Everything will be done by itself, because when I already told you the step-by-step process, that first you have to install R and R Studio. R Studio will automatically detect the R in your computer and it will be interlinked automatically. So you need not to do it. But if you install R Studio first, then you have to manually link it with the R, which is not a good idea, because sometimes the files are not linked properly. So I better prefer in the going of R first and R Studio again. So that is the thing. So coming to this R Studio, now you forget about R, because you need not to do anything with the R side. Now you have to work all the thing in R Studio. As all the softwares, you are having several sections here. I will go through each of the section. This part is known as script editor, where you write the scripts. It is a very little bit small, but no problem. We will see the live version, then it will be very easy to understand. Then you have the second section. This is the console, where you get the output. Means you write the code here and see the output here. With all other softwares like MATLAB also, you have workspace and history files. Whatever you have done here, whatever variables you have created, or whatever tables you have created, or whatever functions you have created, that all are loaded here in the workspace. And there is history also, where you you will be seeing all the commands you have run. So that is the very good part of the R. Now you will be also having help. That is one of the important part. You see here, you have the help inbuilt inside the R Studio. That means you do not need to worry about any command or thing, or you just type here, search the documentation. Documentation is live and you can go through. Help is here also. That will open in another window, but you instantly, if you want, you can see here. If you want to know about any packages, because I told you libraries, as you install in C language or get here in R, it is known as packages. If you want to see any plots, you can see the plots also. And if you want to know about any file, so all these things are available here. So I think that this window is very helpful when you are a new person and you want to realize what R is doing. You can go and you can visualize it. So everything starts from a basic programming, and every program starts with operators and programming language. So I will also start from the same R programming concept, and I will come here on the slides, but now I want to share my R Studio. Is this R Studio visible to you? Hello.
Yes, sir. Now it's coming. It is not visible till now.
Okay, I will share it again. Is it visible now?
Yes, sir. Yes, sir. Now it is visible.
Yeah.
Okay, that's very nice. So I am starting here. Just I will be clearing some screens and all those things. So welcome to our world, and we'll be practically visualizing everything.
Hello.
Ashish
I think
sir?
audio is not coming, sir.
Ashish sir, audio. Please wait for 1 minute.
Ashish sir got disconnected, sir. That is, sir.
Yes, sir. They are coming within 1 minute.
Yes, sir. मैं join कर लूँगा.
Okay, sir. Thank you, sir.
Okay, okay, I just joined. Thanks, sir. Okay.
Ashish sir, please share the screen.
हाँ बस screen share कर दूँगा.
Yes.
Now it is visible, ना sir?
Yes, sir. Visible, sir. Okay. Thank you, sir.
Thank you very much. Just मैं एक presentation और on कर लूँ क्योंकि I have to. So my voice is audible to everybody. No? Thank you.
Yes, sir.
Sorry for the interruption for the technical problem. Now I am again starting it. We were on the main part of our R studio. So you can see that there is an environment. This is a live environment. You are visible seeing. You are having the visual impression. So what I showed you on the presentation, same thing I am explaining here. There is a menu bar. You can go in the menu bar and see many things. What is happening actually? You see here, this is the script window where you write the scripts. So you see there is a run button, there is a repeat button, so you can rerun some code, and you can also find the sources here. Whatever you write, there are two ways you can write. I can write 5 plus 7 on the command line and just enter, and the answer will be denoted here. It's as simple as a command prompt where you use to do it. In the Python also, we do like this only on the command prompt. But the Visual R Studio has given you the power that you can see the console as well. Now, what is there? You can have this command. And if you want to run this single command, 5 plus 7, you write the script here, like I have written. This is a script, and you can see that this is a simple program of diabetes, but I am dealing with this R main code today. So the script is saved as .r file. You can save the script as .r file, and you can have it. I want to also show you about the R also. Is this screen visible to you? This is the standard R. This is a standard R GUI. But it is not as good as R Studio. If you install R only, you will get this window where you have only the power of the command prompt, nothing else you will be having. You can go for packages, but it is not as powerful as this R Studio is. So whenever you use R, you install R Studio also. This will make you much more helpful in data analysis and all the part. So this is the part. You can write the script here, write 5 plus 7. This is a simple command which I am giving. And whatever you select, just press this run button and see the outcome. You can write 5 plus 7 here and get the outcome as 12. You can write in the script and just press the run button, save it as .r file, and you will be whatever name you want to give. So this is the way actually the R runs. So this is the main thing which we'll be using in this session is the screen and the console. This script screen and this consoles. Here you can also see that there is environment. Whatever the data and the values you have created, all will be listed. You can delete here. Yes, I can delete, and the environment will be clear, which I have done just to show you when I will be creating some data types, and data will be going and the values will be coming. Here it is the history. Whatever commands I have run in the past, this history will be showing you. Once maybe you have not run, this will have all the history commands, and you can take it with your side. So this is file. You can create your own folders and add the files. This is the portion where you have the plot. I will be showing you the plots also. This is the packages. So it's just loading. Whatever installed on my computer, the packages will be coming out. It is just loading. So once it is loaded, it will be visible. All the packages you can see, bio generics, bio strings. There are packages for data sets. There are special packages for stats groups and probabilities. There are special plot libraries. You can see number of packages, and each has its own betterment. I already told you that this software is the majorly used by the researchers and the data scientists. So I know that you PhD scholars are all data scientists, and you want to have some part where you can develop data, do then data analysis. So that's why this total tool you can go for and you can use. It is not as specific for engineering only. It is specific for generalized software platform for doing research for any domain, any department. So you can, because once the statistics parts come, R is the most magnificent tool in this doing this about the stats part. Even you can use it for data set, you can use it for computation, even you can use it for machine learning, deep learning, you can use it for engineering problems also, coding, because it is a general language and it is available for all these things. You can write any code for custom codes and you can go it for. So I already told you, you are having help. You can find a topic and do anything. So if I write vectors, so you can see already rough set theory is available here. You can study about rough set. I was writing vectors, so I can show you about vectors also. So anything you write here, this command will be available, and you will be getting all the outcomes here. So this is the way you will be doing. Actually, I'm in the R&D file of introduction of rough sets. That's why it is not showing your vectors. But if you can choose any other stats package or any other package, you can find it out. So you can read many things here. There is viewer also, so you can view all the files also. So this is the major part which I am dealing with. Now let's go step by step and see. So first of all, I will select the arithmetic operation. Everybody do plus, star, power, division, square root, exponential, pi. You can take and you can see the outcomes here. So whatever commands we are giving, 10 by 3, square root of 2, whatever commands you are giving, you can see the outcomes here. So data types. So I already told you, rather than going on the PowerPoint and just flowing the PowerPoint, you can see the live here. I am doing Control L to clear the console, because this is the command by which you can clear the Control L. Yeah, there are a lot of commands available here. You can zoom in, zoom out. Shortcut keys are available, and to clear the screen of the console, I use Control L. So maybe it is not written, even though I am telling you Control L makes the console screen clear. So every time I will be running. C here stands for concatenate, and as you have to do in C languages too, you have to define the data type, but it is not needed here. The R compiler is powerful to know that it is a numeric value, logical value, character value. Just by initiating that quotes, you will be getting the characters value. By writing iota with this, it is a complex value. If you are writing true false, then it will understand it as a logical value. C, again I am telling you, is for concatenate. So concatenate means it combines the thing. Just one I am running here, and I will show you the outcome. So if you concatenate and I just run it, see this variable already in the environment, X is created. You can see here X, a variable. I told you I will show you X, and it has a value of 0.5 and 0.6. Whatever you create this variable, as in MATLAB, if anybody is using MATLAB, you can see that same in the MATLAB. What is done? It is done here also. So X is available to us. Now we are having true and false values. So when you run this, you see the X is now having true and false value. So there are two variables. If you want to take the first variable, it is 1, and it is the second variable is 2. Like this, you can run for all the things. So we are having predefined functions also, which can create the data types all in the variable. So we can use the vector function. So I am just running the second part here, and I'm showing you that this vector has created a complete 10 string, 10 value array, numeric value, and it has 10 zeros. So if you want to create a matrix you can very easily create. You can run the matrix it has created, because I am not passing any value actually, so it is only forming a 2 rows and 3 columns. So you can handle matrices also, and you can handle the vectors also. But if you want to pass value, so if you need to pass some value in the matrix and you enter, you can pass it here, like I am passing 1:6. Now I am running it. So you can see now it is not NA. It is not NA as it was here. Now, if it is not visible, I will be running again. So I am doing Control L. I am running it again. So you can see it properly also. Like I have created a matrix and stored it in a variable M. You can see here data, there is M variable, which is holding value 1, 2, 3, 4, 5, 6. And you can see that I have created a matrix which is of 2 cross 3, means 2 rows and 3 columns, and it is easily visible to all of you. So once it is created, it is available in the global environment. That means that you can use this matrix M variable anywhere, wherever you are running the program. Once you close this, it will go. Yeah, it will be going out. But in the running of the program which you have done, you can use it as long as this data is available here. Once you close this R, it will be going out. So this is the thing you have to remember. So matrices can be created very easily, and you can have it. But sometimes we can want to bind two variables in a particular way. So you can do it by defining it, and you can do by column bind or the row bind. I am showing you the output for each of the things. First, I will be clearing the screen here, and I will run and show you the output for both of the things. See, in this, the first one, the column are binded, means X was 1, 2, 3, and Y was 10, 11, 12. This I have defined here. So first X, you have to write this symbol to get the value inside a particular variable. This you have to remember. And Y will be having 10, 11, 12. And we combined it with the column variable, and see here by X and Y will be combined, and we will get a 2 variable column. So X column, X variable, and Y variable. But if you want to do row binding, means X will be the first row and not the column, and Y will be the second row, not the column in the first case, then you can do by R bind. So you can combine as many matrices, vectors, or any variables in combination. So this is a very helpful power of R. So if you want to create list, as you are creating matrices and other thing, you can create the list also. So again, I am clearing the console so that you can have the visibility of the list. List is a variable which can store different types of data types. As you can see, I am having numeric value, string value, because matrices and vectors store homogeneous data type. It cannot store heterogeneous data. So in order to store the homogeneous or heterogeneous data, you have to create list. So list is one of the ways you can add it. So just I am running it, and you see the list holds the value at particular position with the particular value. You can get the value out whichever L1, L2, L3, L4, whatever. This will give you the value of the particular values also. So that is one of the part. You can create factors also, means yes, no combination. So this can be also done. Again, I am doing Control L. So clear the screen, and we are running this command. So this will be giving how many no's are there, how many yes are there. So this factors analysis factor is given, and you can know which level. So there are two things. There is factor and there is unclass. Unclass means what are the particular levels available in this thing. So no and yes are the two values which are available. So you can use unclass to know the things, and you can know the factor to how many values are available for no and how many values are available for yes. So these are the basic commands, but it is very helpful to understand what is the power of the data types which we can define here. So again, we can create data frames also. Data frames is also available. So we can run it and you can have a frame. Frame will combine different variables and you can store. There are foo and bar here. One frame is in one frame we are taking both the variables. So foo and bar. So we can create data frames also. Data frames are used like as SQL. SQL, you see there is one column of password, one column for name, one column for email address. Same type data frames are created and you can create it easily with different types of data sets. So data frames are as good as list, but are much more useful for data sets creation. So this is one of the way we can do it. So we can also have missing values. So if missing values are there, we write NA or NaN. So there are two types we can show the missing values. So missing values always it is written as NA or NaN. So if there is NA applicable, then is NA is there, then it will be showing true. And if it is not there, then it will be showing false. So that is the way we handle it. So this is the is NA, meaning that to check whether it is. As other programmings also, there are control structure. We are focusing on these two screens. So you can see your control structure. I am just highlighting so that you can understand which particular section I am dealing with. So as other program, you write if commands, there are looping structures. So if section also you can deal very easily here. If and same type bracket, we write the condition and we write the particular way of defining and we will print the outcome. So just I am again doing Control L to run because it will show you the output. See, this statement is run and output will be 10. You can see that if we have passed x equal to 5 and it is greater than 3, that's why the value of y will be 10, else it will be 0. So this way you can do. So if I write here 2 and I take the structure and rerun it, so it will be giving you 0 because this particular condition has failed because x is not greater than 3. So this is the way. Now loop programming is also very easy. You just define the function for inside the parenthesis, the round brackets. We are having I. We define the variable and how much time the loop will be running. We define it and we write the commands inside this. So we are just printing the variables, how much it is going on. So again, I am running it and I am showing you that once the loop has run, it has printed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All the variables are creating here and they can be used in the future also. There are different ways of running loop. So you can write it as 1 to 4 only, 1 to, and you can print it and you can show it. That is the way you can go out. So let's print a variable also, so which will be useful for us. So this is another way of running the storing the value. You define the variable holding. C stands for concatenate. C is not just a C. It is concatenate in our language. It concatenates A, B, C, D, and it puts in X. X is having A, B, and C, and D. Just you have to run it 4 times because there are 4 individual variables. You can print the values applicable. If I write it here 7 and xi is not holding the value because there are no. Sorry, I did not run the whole command. So I will select it. Control L to clear the screen, and I will rerun it. It is in the loop 1 minute. Okay, clear the screen.
Ashish sir?
Yeah, I'm here. Just one. Yeah, that's just I'm opening the file which I created, recent files, and we will start it. Okay, so I am again coming to the part of the for loop which I was discussing with you all. So we were on this part where we were publishing it. Just I want to show you that when we change this value to 7, suppose I change it to 7, and so there are not 7 values, but we have to see it. So what we will do, we will run. So it will print NA. That was the thing which I want to show you. If the values are not present, then it will show NA. NA means I already told you that NA is there. If no values exist, then NA will be printed. This is one of the things which I want to show, and you will be getting an understanding of what is happening. You can have nested loops also. Suppose you are having a matrix and you want to get the values for rows and columns, so you can define that also. So I'm not going with every example, which are important because I have to take a lot of deals, a lot of parts of the machine learning and data analysis. So just I'm running this for loop, simple for loop. Again, I am doing Control L and I am running it here. And once you have seen, you get the value 1, 2, 3, 4, 5, 6. So what this representation here means is 1 to 6 are the values. So you see, but they make it into 2 rows and 3 columns. And once the rows are created as 2 and the column is created as 3, we loop it inside the X variable to get 1, which is the first value, that is 1, 1. And similarly, it will be going. It is a 2 cross 3 matrix basically, and you understand that I is there and jth position. I is the rowth position and j is the column position, and you are getting the values out. Similarly to for loop, you have the while loop also. While loop is very useful for the termination when you want to run in a certain count values. So it will run it and get in a condition. So while is very important. So first it tests the condition and then runs the loop. And for loop runs iterative times. That is the difference between while and for loop. For loops is the iteration number of times you want to. It does not check the condition is tested. It tests afterwards. But in this case of the while loop, it tests first and then create the outcome. So again, I am doing Control L to clear the console, and I will be running this single condition while loop. So when we run this single condition while loop, so this command just I have taken it and I will be running it. So you can see that it is printing 0 to whatever value because I have given count. Count is first time going out, and it will be printing the count. Then it will be adding 1 because first time the value is coming 0, and then it is initiating to be in the loop of addition of 1, 1, 1, 1 each time. Then it will be giving you the value of output. So this is one of the way we are defining the counts. There are other things also we can do for binomial, but we will take it in the further sessions, further slides. Now, major thing is there are different types of next loop also. If this is break, then do something that is done by the next command also. So you can see this next, and next will be doing this value. And once it is done, it will be giving you the X value. So we can, next is used to skip an iteration of a loop. So just I am running this next part because next is break, next, these are used very thoroughly. So see here, once the condition is I is less than 20, it breaks the loop, and next it runs the X and assign its value as 5. What to do when the loop is completed? That is what the next does. So these are the things. But this is for loop. I already told you there is if, there is while. If and if else are both combined, and there is while and there is for. Similarly, you can do functions also. So all the functions you can define here. You can run the function. So this is a function which is run, and the value is coming out to be a to the power 2. This is a power sign. Function is very important. Everybody needs function. Once we write anything, we want to be having a function also. So function a comma b. So and b are the two values which we are passing here. Right now we are only passing a. So just f2, that means that a will be power of 2, and this calls the function and it will give. So this never use the argument b. So calling f2 will not produce an error because the 2 get the positionally matched to a. That means that if you are not passing b, it does not mean that the function will not run. Function will run because function has got the first value and it will be showing you. I am now coming to the practical application of R, because this is the part which I want to. This was just an idea, a glimpse how the programming is done, and now coming to the major part of R programming. So again, I am going to the slide. Please wait for a few seconds so that I can open the slides and I will be back. Is the slides visible, or I have to share it again?
Visible, sir.
R language? Huh?
Yes,
Okay.
sir. R language, R student
Okay,
language.
okay, that's good. So I am again coming to the, because I have taken all the major parts of data types, I will be just flowing through this thing. So I have done all the things. Yeah, I have told you many things. Installing R and all those things are already covered. I'm just going out, and we will be coming to the main part of our data analysis and model development. I have told you about the programming. I told you about this arrow sign when we are defining the value. I told you about all the variables, scalar, vector, matrices, data frames, and list. You know all these things. I have shown it by examples also, how to define it. I have told you that C stands for concatenate. Just I am giving you a review how you can define vectors, how you can define matrices. All these things I have cleared you, so you can understand these things. So this is not the thing which I have want to go, because I have shown you in the live running also what are going on. So data frames also have told you that data frames are made like databases. Like I told you, name, age. Here we are having year and scores, and we want to combine it in a one frame. We can do it. So it is like a SQL data set. So you can have age, gender, disease. This is a data frame. Mostly when we do these kinds of data analysis, we need where the values are heterogeneous, but we want to combine it in a form, and we want to use it. Yeah.
R Studio is visible, sir. Your slide is not visible.
Okay, sorry. Then that's why I was asking. So 1 second, I will share it again. I can go to the controls. 1 minute, sir. Just I will be doing it.
Okay.
Now it is very visible, sir.
Yeah. Now it is visible, sir.
Sorry, I will be going again back to the slides, which somewhere. Sorry, I was not knowing this thing. So I will be starting from the brush through, because now it is visible, man.
Yes, sir. This is R platform assumption.
Yeah.
What is R?
Yeah, that's good. So I have told you about installing R and all those things. I will not go in the future. Just a review, a brush through I am doing here. You know how the environment is looking. You know how the console is there, what the console do. Console give you the outcome. Here the variables are created and the workspace is shown. Here you get the helps to manage the things. R programming, you get all the operators and these things. I have already told you how to do the coding. These things I have completed very well. So data types already I have told you. So scalar, there are 5 types of data types: scalar, vectors, matrices, and data frames and lists. All these things are available to you. There are numeric vectors also, there are character vectors also, logical vectors also. Everything I have dealt in the live examples. I already told you C stands for concatenate. Don't confuse that. C is also a variable. C is a function. Actually, C means a concatenate function which combines all the values. So this is the function. There are other operators also which we are using under the conditions. So just example, I told you about data frames. Data frames we will be using very frequently in the machine learning and the model development and data analysis, because it gives you a data set type of system like SQL. SQL, you know, SQL you make data sets. So same way in the case of data frames, you get like age, gender, and something is disease or not disease. Like this of things of combination, you can handle it properly. So X is the variable and rows and column. X dollar age, X1, you can get all the values. You can query it. Like X is a variable which holds the gender M. So it will give all the values of those particular rows. Means it is a database, data set. Data set is useful for analysis. So we need it thoroughly. It is a heterogeneous. Matrices are not heterogeneous. It is much more like homogeneous, where all the variables are having one particular type of data type. So this is the major difference between the data set and frame and the matrices. So we can use matrices for the simple homogeneous calculation, but for analysis of different types of data types, we use data frames. So that was the major things which I want. There is list also. You can create list also, and same thing list. Like data frames, you can do query list also. List also store the values in the form of heterogeneous data, but it is little bit complicated. So you have to define each values in the list and then concatenate and do it. But data frames are much more better. So we can do better in the way of handling the data frames. So we will go for data frames. I'm not going much more details. So control structures also we have talked, if else, for, while. You can use if else and all those things, and you can generate the program. I have written some programming, simple programs, which you can see that for loops, and you can go on. Each type of things I have already dealt with you. I already told you about functions also. There are numerous functions which are available. You can use it. I was using C as a function. You can do whatever things you want to do. There are a lot of functions available built in. So my focus is now graphs. I will talk afterwards. So many graphical expressions can be done. My focus is major on the data development, scatter plot. My focus is on taking a particular example and applying it on a machine learning problem. So simple programming I am leaving. I am coming to the main objective of this course, because I have already given you the basic ideas. Now I will start with the machine learning in R. So everybody needs to analyze data sets. Practically experiencing, if you want to do machine learning on R, you can go to the UCI machine learning repository. This is the site where you can download the dataset. Dataset can be in the CSV format, any format. It is easily readable by R. I will show you how we read. So there are built-in data sets also. So when you type this command, I will show you when you have data set name, you can give and you can get all the data sets which are built in R. So you can utilize those R data sets also, which is very helpful for doing. Majorly when we do any type of data analysis, there are two phases. One is the training phase, where we make the learning of the model, and there is the predicting phase. Before training and predicting, I majorly do data analysis also. So you saw the topic as data analysis and model development. So model development includes training phase and predicting phase. But rather than doing only the training phase and the predicting phase directly on the data set, it is better to first do some data analysis, analyze what the visual graphics are used and how the data is looking for. So going for these things, I have validated, I have written some steps which should be followed during the process of any research. First, determine the input and output. So this is very important. Suppose I want to make a predictor for the student performance. So student performance generally depends upon the mark, uh, his curricular activities, his attendance, discipline, and we rank it with other particular parameters. Once you have decided and you have marked it good, bad, very good, so this type of thing will be output. Output can be multiple output. Input can be single input as well as multiple inputs. So that depends upon, you have to make your data set familiar, and you should be able to determine what is the relationship between your input and output. Now, what is the thing is that you have to do some feature engineering. So feature engineering means once the data is raw, it is not available directly to the model. So for model development, you need the data should be in the code, which is understood by the particular compiler or the software. For that, we do feature engineering. I will be talking about feature engineering in future. Preparing training data. When we have a huge data set, we divide into test data and training data. The training data is given to the system, and the system learns from those data, making a relationship between the training data and the training inputs and the training output data. So there is a relationship. Well, I already told you performance is the output, and the marks, attendance, discipline, activity, all these are the inputs. So input output relations should be learned per the particular. Without past data, we cannot make any model predictable. So it is very, very essential that you have featured data set. That's why we need in machine learning data. Data is very important. Once the data is determined, you have done the feature engineering, you have trained, prepared the training and the test data, then train the model. So model you can train by statistical model also, and by using machine learning models also, and by using deep learning models also. Anybody who can tell me what is deep learning? Anybody? Yes, participants, you are available, na? So you can unmute and maybe, or
No, sir, they can write in the chat box.
So they can write in the chat. What I will see there. So, but I will tell you that because it is on the chat bot, no problem. I will be telling you that when we talk about AI, artificial intelligence is the base for the future technologies. So, when we talk about AI, we have two domains in AI, which is very, very much prevalent. That is the statistical part of model development. Another is specific to the neural networks. Neural network, artificial neural networks, we have developed a technology based on our brain neurons. As what we are doing in our brain, same way we have developed a model which can predict or which can analyze specific to images, audio, and text. These three types of data inputs, we use deep learning models. Deep learning models are very complex data because they are live data, and they are the same data as what we actually analyze with our eyes and ears, and we hear and we see. So same type of understanding level is introduced in using the deep learning model, and we are succeeding in this technology, and we are making this technology much more. So computer science peoples are very, very familiar with these type of technologies, and you can use in the research for image analysis, video analysis, image classifier, text predictor. So there are certain, because it is out of the track, but still I am giving you the extra knowledge that there are models like RNN and CNN, recurrent neural network, and convolutional neural network. Convolutional neural network handles images, and recurrent neural network images as well as audio you can give, and recurrent neural network is very, very useful for analyzing text. So these type of models are also built, and we can train those technology to train our model. And but we in this particular R is also having the deep learning capability. We are using machine learning model, which is much more statistical. And statistical means we are using statistics as the base for the model technology development, and then using the validation model and deploying the system. So this is the way we do it. So just we start again with the same thing. Determine the input and output. So whenever we define the inputs and output, there is two types of problems actually we solve during the defining the input and output. One is the regression problem. Regression, you understand, there is a continuous numeric quantity that we are predicting. If x is this, x1 is this, x2 is this, x3 is this, then y is this. So next stage will be x2 is this, x3 is this, x4, then the y2 will be this, y1 output will be y2. Then means that there is a continuity in the data, and the all the next outcome depends on the previous entries. So that type of continuous data set, I am talking about multiple regression problem only. But if x1 is this, y1 is this, x2 is this, y2 is this type of problems are linear problem, and we call it as single input single output linear regression problem. But my major concern is that you understand that there is a dependency of the past data on the future data. So this type of continuous numeric quantity dependency is known as regression problem. But if there is a discrete category problem, like I was already talking about the performance of a student, so it is depending, each individual entry is free from the previous entry. And if X student has this marks, this discipline value, this activity value, and this particular attendance value, then he is a good student. This is specifically dependence on the particular X student. It does not mean that it is depending on the previous student's performance, then you are judged. It is not so, because you are a discrete entity and you are having your own values, you can give. So but it is very good that in the category classification problem, we can have a homogeneous data set where we can have the category as number, as or the variable as a number, or as a category. Category means high, low, medium, good, very good, bad. These type of things can come inside the categories. So this is one of the most important steps. So I already told you that second predictive analysis is the feature engineering, because I told you that we follow a step-by-step process. So this is an exploratory exercise, and the domain expert finally makes a data set into a well-defined data set. So raw data set, sometimes you need normalization, sometimes you want the category to 1, 2, 3, all types of these type of working but done by the domain expert make it very easy, and you get a data frame. That is the part of feature engineering, and we combine. That is first is the raw data, then we combine it to be understandable to the particular software we are using. So this is known as feature engineering. Converting raw data into the software understandable data is known as feature engineering. So this is one of the part which we do in the in any data set. So we will make it in the form of data frames, and data frame in R is a common way of making feature engineering. So I already told you that making a data set which is understandable to the computer or the R package, we use data frame, and we will be going inside it with the problem. So let's start the problem and see with the predictive analysis. Again, I am switching to the slides, because here if I run the slides, it will be not be understandable. I will take it by running on the computer itself. So again, I am coming to the our R software, and I will be going to each step, specifically how we can run the system. So first I am doing Control L, because it is necessary, because it affects the can I ask you, are you able to see my R Studio screen?
Till now, no, sir.
So again, I have to share it. 1 minute, sir. Is it visible now?
Yes, sir.
Okay.
Our main code.
Yeah. This one part. Yeah. So I am now again showing you step by step how you can apply R for model development and data analysis. So let's start with a general data set. This is available inside the R software, and this name is Iris. So Iris is a data set to classify a particular type of flower, and it is a very common machine learning data set, and it is available inside R. So if you are not having a data set here like this which I am taking, you can just upload it in the CSV format, name it as a variable, and you can take it. It is not at all an issue about loading a data set from external sources. Also you can do it very well inside, but for the simplicity, just I am taking the Iris data set. I am running this code. See, this data set is a complete data frame, and you can see here there is a sepal length, sepal width, petal length, petal width, 4 inputs and species as the output. This is a category problem because I am taking as a classifier problem. We want to classify the system as 3 types of flower. These are the 3 types of flowers I will be showing you. Setosa is there, versicolor is there, and virginica is there. So these 3 types of flowers categories each has its own data set depending upon the sepal length, sepal width, petal length, petal width. These 4 are the inputs. This is the output. I just loaded the data set, and data set is available for data analysis. So I am having all the data set. If you want to see the first five data set, I am again doing Control L because it is easy to show you. I run first 6 data sets. Sorry, so first 6 data. If you want, then you can directly write head and Iris the data. It will show you the category first 6 data and their individual inputs. If you want to know the rows of the columns, anything, then you can also do it, and you will be having that the total data set is about 150 data features are there, depending upon the length, width of the petals and the species. So each row is there, and the total rows are 150. If you want to see a particular data feature, like I want to only see the species, so I can see the species also. Just I am running here species. See, very beautifully it has shown that Setosa is 50, whereas versicolor is 50 and virginica is 50. Why it is have given? Just because you have use a query inside the table. So you can query the table and you can get the values or number of values and whatever. I already told you that it is not that the system is or R is only for giving the numeric data analysis. It is very good in plotting also. So we will go to the plots also. So first of the plot which we do on the data analysis when we have the data set is histogram. When you are writing your PhD thesis, there is statistical visualization also. Everybody wants to visualize what my data is actually looking at. So I will start with the particular histogram plot of each data sets, like it is taking the sepal length. So histogram is very, very good for the frequency, knowing the frequency plot. And this gives you the idea of the frequency distribution and all those things. So I will just show you for particular sepal length only, and we will see the density plot also. So when we take it, just we will run it. We will be running it, and see here the plot is available. Plot is available here on the density. You are getting the bars also, because it ranges from 4 to 8. The values ranges because 5, 4, or whether 6, whatever the value you see. The curve which is at the topmost. This is a smooth curve is showing on the screen. I am handling with my arrow. You will be seeing it. If you want to zoom it, I can zoom it and you can see it clearly. One good thing of R is that you can export it in the any image format or the PDF format, and you can use in your thesis also. The picture is very clear and we can use it. So export is also available. Zoom can make you, this type of graph plot is seen. And you can print screen also if you are having problem with the resolution, and sometimes the people ask for resolutions also. So you can take the resolution, high resolution, and save it with a particular software so that its resolution is intact. Because in the research papers, many times it wants the images to be very clear. So you can use those high resolution software which can convert the images into high resolutions. So you can use those. So this is one of the figures which we have taken. Don't go that this is a very blurred image. It is not blurred. It is in reduced size. So that's why it is showing like this. But the picture is clear. So you are seeing the bar plot as well as the smooth line plot. So we have done the histogram plot also, and we are done the line plot, density plot for the particular thing. You can do it for the categories also. And this is also a beautiful plot. Again, I am doing Control L so that clear the screen. And just I am running it. And you can see it is showing Setosa, versicolor, vaginica, all are 50-50 values. So the bar is on the same size. You can zoom it and see the particular values and on the graph. So it is, you can categorize and see that these are the steps which we want in the research papers. Whenever you do PhD and you write thesis and you want to show your data, you have to show visually also, because the or the examiner wants that, the reviewer of the thesis wants that that visually he could understand what the data you have actually taken and what its representations are meaning. I can understand that there are the 50-50-50 are means that equivalent values have been taken for each category. So it is very clear that it is not a biased type of model development. Every category is dominated and has its equal domination or equal contribution in the complete data set, because data set is very important. So you can get an idea about the bar plots about these things. One more very beautiful way of understanding the data is box plot. So we will do the cross validation type of box plots. So I will be showing you the box plot also. Just I am taking the box plot and I am running it so it can show you. So box plot one again, I will be showing here. So box plot shows you how much is the relationship between the data. So this is one of the way we can represent the data, how data is well concentrated. So this shows that Vaginica is very well concentrated, and Setosa is on the 5 range, 6 range, 7 range. So box plot is very helpful for an analysis of such kind of data. So distribution, so which you can understand this is as the distribution of the numeric value. Means scattering of the data is one way, and you can show that the data is in between this range. So I can show you that when we zoom it, the data, the average data is of value of 5. Here it is 6, average value is 7, and this lie in between 4 to 6, 7 range. So this is the box plot meaning actually. So you got the box plot also. So you can show in the thesis histogram, you can show the line distribution, you can show the bar plots for the specific category. You can do it for multiple data set also, not that only one category is there. Everybody is having their own problems. You can show in the format. Next is scatter plot. So I am running the scatter plot. This is one of the way the complete data set is analyzed. So I again zoom it. You can understand each individual points. So how these individual points are there. So scattering based on sepal length and petal width will be shown here. And similarly, every data sets is shown in the screens. So this give you a complete idea about the input correlations, how correlated, well correlated these data are there, and whether we are able to analyze it in the format so that we can predict the outcome. So inputs are, correlation between the inputs can be done by scatter plot. So this is one of the way. So correlation matrix is needed. So you can see the highest correlated is 1. You know that sepal length with sepal length will be 1. But you can see here in the numeric also. This is the visual plot. This is the correlation plot between each variable. So you get the complete plot for the correlation matrix. Distributions you have already done with the box plot, and the frequency plots so you have done, the bar plots also you have done. So I think that this is one of the important part, that you should do correlation matrix also, and visualize it using the scatter plots. So this is one of the things which we want, very useful for understanding. So I think this is clear to you, what it's the meaning. So we can plot a relation between two variables also separately also. So there is a simple plot of this one. So I will just take this first plot, and I will run it. So you can take separately individual also. So it's not that you can get only the relationship between all the things in the scatter plot, but if you want to only know about petal width with the sepal length, because many times that scatter plot become cumbersome and you're not able to show in your thesis work. So but you can show individually and mark it out that how well correlated these petal length and sepal lengths are. So because each individual will be having their flowers, sometimes a petal length width is small, but the sepal length is high. So these data will be coming in this region, but there is no data. But major data is where the sepal length is 6 and petal length width is going up to 2.5, 1.5. These data are very dominating. So you can understand the domination of each data point with respect to two variables. So this is one of the things which we analyze using the relationship between the two variables using our software. So if you want to print the linear regression model, you know that I talked that if there are multiple regression problems, then you have to define x1, x2, x3, and then y will be coming. But in a linear regression problem, there is two variables, and you take those two variables, find the regression between them, and you can plot this. So I am just showing this thing here. So I will show only the simple line problem, so which we can run it. So you can see the same regression has a linear line showing. This is y equal to mx plus c. So you have got the mx plus c line, and you can see how well the data is distributed along the line. If it is analyzed inside the line, then you can say there is a relationship between the sepal length and petal width, and you can know it by correlations also and all the statistical parameters. But still, it is giving you a visualization. And R is very useful software for this kind of regressions: scatter plot, box plot, bar plot, histograms, distribution, all types of plots, data analysis I have showed you. Now the time is
सर कुछ एक स्टूडेंट्स को पार्टिसिपेंट को स्क्रीन विजिबल नहीं हो रही, प्लीज आप एक बार इसको दोबारा शेयर कर दें.
हाँ ओके
थैंक यू.
सॉरी, आप बता दिया करिए अगर कोई प्रॉब्लम.
नहीं वो अभी मैसेज आया था करेक्ट पार्टिसिपेंट.
हाँ सॉरी सर, मैं बस शेयर कर रहा हूँ. आप विजिबल है, फिर से मैं रिपीट कर, नहीं उनसे भी पूछ लीजिए एक बार.
यस सर, श्योर सर, कंटिन्यू.
नहीं तो मैं फिर रिपीट करता हूँ जहाँ से मैंने, क्योंकि मुझे नहीं पता चला.
नहीं कंटिन्यू नो प्रॉब्लम.
Okay. Again, I will be repeating for the persons who were not able to see the screen. So I am doing a step-by-step process of research. So data analysis and model development are the two part of the research. So we have to know how the research is started from first, defining input variables and output variables, then combining those into a feature data set, then using that table, then doing the data analysis. Where data analysis we use the plotting system, where we give the variable plots. According to that variable plots, we make a model, and model we will be developing. So again, I am clearing the Control L. Everybody is able to see now, because I am repeating it again for our
Yes, sir. Yes, sir.
our participant, because they are not able to visualize.
Yes, sure.
Okay,
Visible.
so sorry for the problem, because I was continuously saying, and I was not knowing that you are not able to see. So Iris is the data set which I took. Just loading the data is simple. I load the data. This was the loading of the data, which I got the classification of flower problem. There is width, length. Suppose you are a mechanical person. You want to know the fatigue of the workers. How fatigue is there in the industry? So you can have some parameters about the working hours, the environment, the heat, and other types of thing, and you can classify that this particular industry is having high level of fatigue. And you can make lot of data set from going to specific industry. Suppose somebody is working in Agra, where I live. There are a lot of glass industry, shoe factories. So there is lot of fatigue inside the industry. So it is a very common problem, and the people do research, and they come to the data analysis, make a predictor, and then they give their solutions for those problems. So a predictor model is a very important part, that we have make a general model which can predict whether the particular industry, one learned from the data set, it can predict that whether this industry is having a fatigue problem or not. So sepal length, sepal width, petal width are the four parameters here for classifying the flower problem, not the fatigue problem. Just I was giving an example. So species I am classifying. So I loaded that data set. You can see the first 6 data just by running this command, head iris. So I run this command, and you see 1, 2, 3, 4, 5, 6. All the data sets are available here. And sepal length, sepal width, petal width are having these values, and the output variable species is having this value. This is good. This give you the idea about the number of inputs. You can know the number of rows. There is 150. You can know the number of species and what are their names. So just running it, it gives you number of setosa or versicolor or the virginica as 50, 50, 50. This is a equally distributed data set with the output categories. So it is a very good data set. It is not at all biased on a particular category, but it can give the output depending upon all the categories. But if it is not here only, we stop the research. We want to see the frequency distributions also. How well frequency distribution of each variable, not the category variable, the input variable. So that we do by using the histogram and density plot. Just I'm running the histogram and density plot, and you get a beautiful plot in the, sorry, I am fast, but you see here the plot is there. Just click the zoom button and you get the beautiful plot here about the sepal length, which is one of the input variable inside the research data set of iris. So you can see the density versus iris length. Length varies from 4 to 8, and this is the distribution. Majorly the length is
this is not visible, 6. Sir. This is not visible.
So I will close.
Please zoom again.
No, sir, it is not visible because I'm unable, because individual screens have to share. So you can see here only. You are able to see this histogram of iris sepal length? Hello?
Sir. Yes, sir. Yes, sir.
So I will show here only.
Yes, sir. Okay.
If you click zoom now, it will become large and you can see the screen also. So I'm not making zoom here because I have to again share the screen for that particular screen. My whole computer is not shared. That's why it is having a problem. And Zoom is not having that option, I think. Sharing the whole computer. No problem. The histogram is available here. So you can see the histogram plot is coming here. This is one of the ways we can see it. Now, you can do bar plot also. So bar plot is for the output variable. Histogram plot is done for the input variables. Bar plot is done for the output variable. So you can see Satessa, versicolor, virginica. Fatigue can, for the, not take this example, if there is fatigue, fatigue can be high, low, medium. So it will be high case, low case, medium case. Somebody in, I think in disease, somebody is relating in the disease, it can give it in the classification of normal, severe, very severe. So any problem, any way of data set is there, you can visualize it and you can show in the plots. And that is what actually is needed when you do research. Because when you publish a paper, a research papers should need some data analysis. You know, when you write a paper, there is a sections. Everybody writes, just I am giving you an example, that there is a title of the paper that is very, very important, that should focus on the work. There is an abstract which explains about the particular problem. So when you write a paper, the abstract should, I follow is that I want to focus on particular points in the abstract. That is the background, objective, methodology, and the result. So somebody call it as BOMR model. So background should be given. What is the background of the problem? Whether you are working on the fatigue problem of a mechanical industry and you are having this thing. Objective is to know the fatigue of the people and what cure can be given, and development of the model to predict this thing. This is the objective. Methodology is the part where you define how you are doing it. So which type of technology you are using. That should be mentioned in the methodology. And even you can give the analysis part. Sometimes numeric value also enters into the abstract if it is very, very important to that methodology that we have gained this type of result. And result should always say that what outcome should this outcome will, how this outcome is helpful to the research domain and the research scientists. So this will help this to analyze, and for industries also, research domain or the specific domain where you are doing that. So I will write that this will helpful for the industry for analyzing fatigue and improving the working habitats and all those things. And the research world will know which particular variables are important, and these type of things makes a abstract. I'm going a little bit out of track from R, but it is necessary to know you what is the way of writing the paper. Once you have done that, then we write the introduction. So many people think that introduction is very simple to write. No, not at all. It is not at all simple to write. Introduction should give you the complete analysis, what actually the problem is, what the other people have done in that. So this is the part of the introduction, and I always write introduction in subcategories. What the problem is, what his people have done in the past with specific work, and then that means that you have to do you have to write all about the particular reviews, what is there. I also end with the motivation. I always write motivation there. What is the motivation behind you to take this topic? I also write the objective inside the introduction, and then I move towards the background. So introduction should always cover some subtopics, a little bit introduction about your problem, the past review work, then the motivation and what objective are there, and you can define the results in the conclusion part, but this will be done.
Sir, yeah. Screen is not moving good.
No, I'm not telling it.
Okay, sir.
I'm not doing that, but I'm explaining how to write the research paper.
Sure.
So because these are PhD students, so they should know. So that is the part. Which you have to cover. Then in the second topic in the research paper is the background. Background defines the what technologies you are using to develop the methodology. Then talk about the methodology. You have to do in the methodology the complete data analysis. This part which I am doing comes inside the data analysis. Where you have taken the data from, what are the statistical values. This is the third section of any research paper or any PhD thesis. So my complete and third section and the fourth section. Fourth section is the result, and then you give the conclusions and you write the all the reviews. So this section, what I am talking about in the research paper, research thesis, it comes inside the methodology part. So all the things is very important to know when you are writing a research paper, because many times the PhD scholars complain that we have written a paper and it is not published in a good journal. So the problem is not with your work. The problem is now in the representation. You miss some particular things which the research paper should contain. And this part is very important, that you give the data visualization in the methodology part. And that is why I am dealing with this type of problem. So one thing is very, very important is that you have to give data visualization, because it helps us to understand how the data is actually behaving. So now, once you have given the visualization, I have shown you the different types of plots, like bar plot. Another plot is box plot, which gives you the analysis of distribution. This is a box plot. You can represent the box plot. You can represent the multi-variable scatter plot. So I am having this you can visualize the scatter, all the plots here. So scatter plot will come here. See, it will change. This is a scatter plot. I cannot zoom it because right now when I'm zooming it, the screen is not shared. But you can see that the each variable is there, and their correlation visualization is there, and the values are coming on the console part. You can see there are 4 screen sections. One is the script section. One is the environment history section. This is the section for visualization. All the things are now coming inside the plot part. And we can see here there are the correlation matrix is there, where we are having the relationship between each variables. Like sepal length to the sepal length, the correlation value is 1. That means that it is each variable with its own is always having the highest correlation. But if we are having negative values, or some values are very, very low, that means that they are very uncorrelated or negatively correlated. So they can be their value, they can be there in your data set. Problems are always because they are natural data sets. So if there is no relation, that means that some problems are there and we have to tackle. So we have to do some feature reduction, or we should avoid those data sets to be included inside, so that the correlation should be formed in the particular. If you add, if you take noisy data also, the model will be much more better. I think I mostly prefer that what is the natural data that should be taken. We should not have much more curation than inside the data set. That depends on the problem. Sometimes people make the data highly correlated with the input variables, so the outputs is better. So so that is one of the part of feature engineering also, which may or may not be liked by the peoples. So this is the one of the part which I was talking. So you can see the scatter plot relation. But if you want to see the relation between one data set, you can just write the relationship like this command: plot petal.width. This is the sign, and I don't remember the bit. This sign is available on the apostrophe, I think. So apostrophe sepal length, then we take whichever data set we are taking, that is available in our data. So we are taking the iris data set. So we are having that iris data. So we are taking those data, and just we have to click this run button. and see that petal width and sepal width, what the relationship is there, and whether they are correlated. But the correlation is better known by regression lines. So in a visualization form, so I will plot a regression line. So when I run this, you will be seeing that a line has been drawn between the petal width and sepal width. This means that this line is a regression line which is plotted between the petal width and the sepal width. That is very important. So you can show that my all variables are related to each other. See, I'm not giving you the learning of only the software. I am teaching you how you do research also. So my focus is not only that, because you are all PhD scholars, the participants are mostly towards the PhD. So I am talking little bit of your research methodology also. So writing research paper, because this is a workshop on research methodology. So you should know that part also. So only not learning this part. So you can do colors also. So lines, you can draw the colors also. One of the way is that just this one. But if you want to show in the color lines also, how non-linear lines can be there. So we do a non-linear line model also. So some relations will be showing in the red color also. So this is a local linear model. Local linear model is not a linear line, but it is a curved line which show the domination of the relationship between the petals length and petal width and the sepal width. Now, when I have come to this part, my next part is that do feature engineering. Data analysis. After data analysis and all those parts, this feature engineering has to be done to train the model. Without model training, I cannot move ahead. So data preparation is one of the part of the feature engineering. So I will be talking about the sample data. So how you can select 10 data. So we want select 10 records out from iris with replace true. So sometimes we want that iris sample 10 samples to be snatched. So simple, we can run and we can have the 10 data. So and this data set will be ready with us. So this 10 data, 79th position, 32 position, 108 position, 145 position, because 150 data sets are there. We want 10 data only, and 10 data we want to randomly 10 data we want to take. So sample data can be taken. I just giving you an example. You want 150 data randomly selected from your data set. So and you're having 1000 data or 200 data set you want to randomly select it. So you can select it and make it as a variable, as iris sample or a frame, data frame. I will not talk it as a variable, as a frame, because the square brackets are for frames and we will get those values. Sometimes our data set has NA. Suppose there is this value becomes NA. So I have to fill it because that data was not available. So there are two methods. Mean method, take all the mean of the complete particular column, and wherever there is NA, you replace that. That we do in using this fixed iris problem. Fixed iris is a value which is we have imputed with the mean type of missing data. You understand that there are some missing data. So I'm just creating an example for here. So I will show you. So this impute fixing problem can only be done by using the library which is available with R is by E1071. This is a very important problem that sometimes we have NA values. So we will run it and we will see it. See, when we have run it, we got this NA. You see here, so NA is available. Sometimes that value does not occur inside and it will not make your system trained, because if you write NA, so NA, the computer language, when it will be going for each data set, it will not learn and your model will be not working correctly, because it is a absurd model, because there was NA and he has learned NA. And you have to give, if there is not a number inside any column, you have to either replace it by mean or you have to replace by median. So I will fix that problem of missing data by using this library and creating that this particular iris sample as a fixed sample where NA will be removed. So see here, I am running it, and see here again it has replaced that data with the mean value. So this has replaced, and it has made your data completely numerical, and you can now use it for your computation. It is not so that you can do it for only for particular iris variable only. Any variables you are taking and you are not having any value, then you can replace it. So again, I am showing it by median. So median also replace the value. This is done by mean. This is done by median. So you can have two ways of replacing the value. Sometimes you have to do it manually also. You have data and you did not find that this person has not got the attendance. So I cannot classify the performance of the student. So how you will be doing that? That can only be done when you are replacing that particular value with a particular numeric value. That is done by this fixed problem. Now, sometimes we want to do the normalization. So normalization in the numerical sense is that x minus mean x upon standard deviation. See, there it is 6, 5, 6, 4, 6. I will normalize this value. So when I normalize the iris value, so I will show you the head of the, which will give you first 6 value. I am running it. See, all the values comes inside -1 or -2 normalized format values which can be used. This is a normalization function which you can give your own value of 0 to 1 also, or you can normalize it with the sense of standard deviation also, which make the understanding of, because sometimes the value is 0, 20, another value is 1000. So when we are training those model, we are unable to train because the 1000 is very, very far from the 20 value in a particular column. So better to normalize it in between 0 to 1. So the model learning increases, and normalization is one of the way we can cure the data. So this is one of the feature engineering problem. Sometimes what I find is that this particular variable is not very, very important. So this variable should be eradicated or removed from the data set. So how you can know that? This is known by principal component analysis. So whenever a variable is not particularly correlated, we do principal component analysis. If it is highly correlated, then we take that variable, or otherwise it is not correlated, we remove it, or we find the dominancy. So that can be done, and we can reduce the dimension. Suppose I am having 5 variable, 1 output. One variable is not at all important because it is not showing the correlation with all the variable. Then it is not useful to keep that variable. So we do principal component analysis, and we compute the correlation vectors and compute all the things, and we just remove those things. So this is the way we do it by PCA. I will not go through detail through the PCA. Just I am running it and showing you how the components are related, and whether we have to remove those variable or not. So correlations are calculated, and we can see there are PC1, PC2, PC3, PC4. We see which variable, which PC1 has the highest value. We take that PC components and we remove all the things. So wherever negative things are occurring, I will remove this PC3 model, and this gives me the idea that in the sense I can remove petal width, but that depends upon the PC values which you are doing. So PC values are very important during the dimensionality reduction. So this is one of the things which I have talked to you. Sometimes we want to transform our variable with another ratio value, so that the dimensionality increases with that particular thing. So we can add any attribute to our input data set by transforming transforming the data. So I am here taking the ratio of sepal length and sepal width, so that I make a data set which is another data set which has this new column added. So adding a attribute is also possible to your data set. So simply now you see we were having sepal length, sepal width, petal width, species, and ratio. So ratio is now added. Ratio is again another column which is present inside your data. You can take it as an input and you can also predict it. So that depends upon how the expert domain needs that particular variable which we have created. In past, it was having 5 variables: sepal length, sepal width, petal width, species only. So you do not have ratio, but ratio is created by transforming the complete iris data set and getting the ratio of sepal length to sepal width and rounding it to second highest value. So you see that dot 46. It is not 4678 because I have mentioned 2. So if 2 is written, that means that this data set is useful for us. Sometimes somebody use the equal width cuts. So sometimes we want to cut the data, cut the petal length data to a particular point. I want the segmentation of the data. So we can do the segmentation, discretization, the numeric values into categories. This data set is first segment of petal length and sepal length for setosa. So we can give that type of formula also. So just I am running this cuts, and when we will be showing it, we will have the cuts in the range of the data sets that it has divided a whole data set into 6 categories, 6 lengths. So we have the new data sets of 6 lengths. Sometimes we want the frequency upon height. That is important if anybody needs. So these all methods are there, which are important, but I do not prefer much to be divisions or those you can go. But now I am completed the data analysis part, but more of the focus is now on model generation. Very, very important part is to develop the training data and testing data. So data analysis is one of the part. When you are doing a research, you have to make use a technology and make a predictor system. So always divide the data into training set and testing set on particular IDX. Means I took the complete length, have the division to 5, and divide the complete data into 95% of training data. This line is 95%, percentile 5 means that it will give 95% of training data and 5% of testing data. So all the data from the lower side, 5% of data will be taken as the testing data. That's why minus test IDX, 5% data will be taken from the, because this will give you about 1:150, then it will be around 142, 143 maybe. So that will be the data which will be taken at the length. That will be taken as the test data from the bottom side. So 142 to the particular length will be your testing data. Minus is there because it will take from lower side, and training data and testing data will be in the range. So this particular will be preparing our training and testing data. I'm just running it, and you have got the test data. So just I am writing in the lower side IR test. So I will show you IR test. Iris test. So iris test I am taking. So it has taken the data 5, 10, 15, 20, 20 percentile 5 पर वो अपने आप randomly data को took up करा, और this particular variable पर इसने data ले लिया. That is that we are available with the data by 5, 10, 15, 20, 30 and 150. So this data is available as the iris test data. And this data is available. Iris trained data will be the remaining, all data will be coming to iris trained data. So you got the data set. Once you have got the data set, 1 minute, I am just coming to that part. Sorry, 1 minute. I'm just seeing where I left it. I did not take this neural network. No? Okay. I took this. I took this. I took this. Explain to you. Okay, maybe. I'm not remembering where I actually. No problem. So this prepares the iris data and the training data set. So we are on the model generation part. Yeah. Any data set. I am not remembering which particular section I was talking. So no problem. I will be coming to the model development. There are certain sections of model development. So I will be coming on that part majorly. So when we are developing the model, we need the train data and the test data. So one way of defining the test and train data, we can do it. Here, I am taking a special type of training model, developing a model, and it is very useful is neural network. There are a lot of method in machine learning. There is simple neural network method. You have SVM, support vector machine. You have Bayes method. You have other logistic regression method. This is a neural network method. This is SVM method. This is naive-Bayes method. This is k nearest neighborhood method. This is a decision tree method. And then we do model evaluation. So first I will develop the model. Once the training data and testing data is available, we will be doing it in the model development. So I will take the neural network method. Just I am taking the whole training method and I will explain you what actually the particular thing has done. So it is not possible to run everything to X, but I am taking neural network to get the model done. So it will take a little bit of time for training. Once the training is done, the model will be available and the prediction will be done for setosa versicolor. You may not be able to see the model. Are you able to see the neural network error?
No, sir.
Okay. So 1 minute, can I share the screen so it will be available to you?
You have to share whole screen, sir.
I will be showing it. Now it is available, sir.
Yes, sir.
This model is represented, na?
Yes,
So,
sir, yes,
so see here, this is a neural network model. So neural network is a way how our brain learns, na? Same thing which I have coded in R. I can give sepal length, sepal width, petal width, 4 values, and classify it as setosa, versicolor, virginica. The model is already trained. The error is 1.17, and it is a very low error. And the steps it taken to learn is 13,000 steps. In 13,000 iterations, it has learned about this classifier. That if you give any sepal length, sepal width, petal length, it can classify it as a general category of setosa flower, versicolor flower, or virginica. I am telling a general model for this flower classifier. You can have here for fatigue also, for disease classifier also. Suppose you are doing research on disease classification. Suppose somebody is doing on coronavirus and whether the patient is having corona, not corona, high corona, or normal. So you can have build a neural network model, have certain values, parameters as decided, cough is there, fever, and there are all other problems, a headache. Then you can take another variable for that. I think something related to corona you can take, or 3 variables also you can take and make a model, and you can classify that disease is occurring or not occurring. So this is one method you can develop. I have developed for flowers. So this is the thing. This screen is able because I'm closing this shared screen now. This sir, now the R screen is available, R Studio.
Yes, sir.
Okay. So you saw that when I was running this neural network model. So everything inside the neural network was very easy to train. Why? Because I was using the library neural net. This is the library which is built inside R. You need not to write a complete neural network code. That is the basic beauty of R. It has libraries, pre-built libraries. Just pass it the particular values. So what here we have done, we have passed Setosa, versicolor, Virginica, and it binarized it. Binarized it because any model does not understand string values. It understand only binary value. It will it will make it understandable only when you have given it 0, 1, 2, any value which is there. So you bind it in the column that all the species with Setosa or versicolor and Virginica should be either 0 or 1. So binarizing it, whether it is Setosa, then it is 1. It is not, then 0. 1 and 0 values we have classified it. So this way we are having binary values. Then we have the inputs. We define the input. We are giving the input as sepal length, sepal width, petal length, petal width. Creating the values, building the model. Just neural net we are using, and we are building the neural net model, computing the testing data, and showing the results here. So this is the predictor model which we have developed. So it is very easy inside R to develop the model and giving the table of prediction. You understand that Setosa, when we have the flower as test as Setosa and it is rightly classified as Setosa is 10, when is versicolor, then all the 10 are classified properly. When it is Virginica 7 is good, but 3 are classified wrong. So our model is very good and it is having a very few rates of wrong classification. Only 3 prediction is wrong. So this was done here. This one. So prediction model of we created the prediction model, and we pass the test values and see that the table is there which gives you the outcome. So every model development has a last table like this, which shows that how well classified your testing data is, because training it has learned very good, but maybe in the testing data it is not learned so good. So we have to pass test data. So we have passed here iris test species to the prediction model which we have developed, and this prediction model will make the classifier for the particular IDX value which we are passing from iris test. So that particular species model will be passed, and whether we are classifying it good or not, it will be available. So same thing you can do with SVM also. So SVM also, you can make a model, support vector machine. This is a support vector machine model. It will run out and it will be classifying the support vector machine. This is the classification of support vector machine. You can make a model for naive bees. So when you write a research paper, you have to give the different classifier, and according to those classifier, you have to make this table and analyze it. I have analyzed it with NN, K nearest neighborhood, naive Bayes, decision tree, and all those things. This is for the K nearest neighborhood. This is I'm not going in the part of the how this coding, but just I'm showing the outcomes. So these are very important tables which show that how better your model is working out. So these petal length, petal width, mostly every model is classifying the Virginica as 7 good one, but 3 it is classifying wrong. So my model data set has the classification for all the technologies or the model technologies, and we can make a evaluation table. So when we talk about the model accuracy, model, how well model is there, we talk about precision, recall, specificity, and accuracy. These are all the particular terms. You can, TP stands for true positive, true negative, false positive, false negative. So you can take the numbers from here and calculate these values and put it in your research papers or research work. So this is the major thing which we use for the prediction, and we can use it for getting the values outcome. Now let us also plot the ROCR plot and see how the plots are there, and we can also do the precision recall plot. So relationship of precision and recall can be shown. This is one of the important tables which we need when we are showing our data set. See here, the precision versus recall is there. So instead of only accuracy, we talk the model values in terms of precision and recall. So our precision is very high. So the model is very good, and we can say that our model is behaving properly. So this is the precision recall value. Another common plot is the ROC plot or ROCR plot. So this plot is between the sensitivity and the specificity. These are all statistical terms. This is also known as AUC curves, and we can plot this AUC curve also inside the R software. I know that you are not understanding with the codes, but these terms are very important, and you can get the relation between true positive rate and false positive rate of classifying how well your classification is done. So these types of plots are plotted inside the model development. So I have covered most of the part from data analysis to the model development. I told you in any research, what you have to do is you have to do 5 steps. Again, I am coming to my presentation. I am sharing the screen of my presentation. Is the presentation available, sir?
Yes, sir. Yes, sir.
Again, I am coming to the part because I have shown you all the runnings of the part. Just 1 minute in R programming. So we were here on the machine learning with R. I was talking about 6 steps. First step is determine the input output. I already dealt with this thing, feature engineering, prepared the training data, training a model, then validating the model by giving the prediction capability and testing it statistically. And last is deploying the model in the live servers. If you want to go for industrial purpose, then these can be done live. So how you do this live? You can make a web server, you write a website, add this program inside that website, or the model, call this model inside website, and you can run it and deploy it, and you can use it for the purpose of for the commercial purpose also. So that is the deploying the model case is one of the industrial thing, but academics, we do the research only. We have done the feature engineering, all those things. We have seen all the plots. So we have seen the single variable frequency plot, hist command and lines command, and we saw that these are the basic representation. We saw the frequency plot, which is very important. We saw the box plot, for the distribution. We did the feature engineering. This is the second step. We see the scatter plot. We see the correlation matrix of the scatter plot. We got the what we call the relations between the regression models. Now next part was coming out was the data sampling. We did the data sampling, created got the way of how we can take the samples out of our data set, impute missing data. I talked how to impute missing data. If NA is there, then you can fill it up by mean, or you can fill it up by median. If there is data are very noisy, means there is no data available, then you can use this impute function. You can normalize numeric values on the basis of standard deviation and mean. That means that normalized data is about transforming numeric data into a uniform range. Whatever range you defined, you can get and scale the data. So scaling is very important. Scale means to get it inside a particular range. So that is, we do normalize data by subtracting average and then divide them with the standard deviation. So x minus mean x, and we take the data, we subtract with the mean data, we divide it, and then we use this data only for training. So sometimes we to reduce the dimensionality of the training data, we use principal component analysis. I'm not going inside the technical aspect of principal component analysis. We can remove particular data and make it shorter by using PCA, the high low level, which values we see, and we can eradicate one of the data variable. That is done by principal component analysis. So here you can see this sepal length, sepal width is completely uncorrelated. So I can take petal length, petal width, and sepal length, which are related, but sepal width is not related. I will remove this data sepal width because it will be giving low outcomes. So this is the way we eradicate the value, because this plot will explain much more better which to take and which not to take. Sometimes we want to add our own attribute or the category or the variable inside the complete data frame. We can do that by adding the functions. Now, sometimes we need the discretization of the numeric values into certain categories. We can do by the segment the data basically. So segmentation means cutting the data in certain levels, and that also we have talked. We have talked about binarizing the data into some binary values. Like if there are 3 variables, then we can write 000 for setosa, 001 for versicolor, and 010 for another value. So this thing can be done by simple binarize. So binarizing the category. So we have done this binarization of the value by using the binarize function, which is very important. You have learned how to use the binarize function so that we can make the particular like first value has the value as 1000. That means that this is a setosa value. So this way we can classify the value. 100 stands for setosa, 010 stands for versicolor, 001 may be standing for virginica in the coming thing. So assigning 1 and 0, we can make the variables output into binary form, and this value is easily learned by the model. So it cannot understand string value. So all strings should be converted into numeric value. That is all what done by this binarized function. If you are having in the input also, then also you have to do this binarization or convert it into a numeric value. So selecting a particular data set, you can select the data set and do it. So I will not take much more part of this data because it will be combined. It is another example. So I will not then go for that particular thing. But I have told you taking iris train data and iris test data. That is the part of the selecting the train and test data. Then train model is here you develop a real model. You can develop linear regression model, logistic regression model, neural network model, support vector machine, naive Bayes, nearest neighborhood, decision tree. All these models can be taken and can be used for classification or regression problem. Our problem is a classification problem. You can get the summary of the data, because data analysis need mean, median, mode, all those things you can do just by summary of the iris data. This I have not shown. I will show you how the summary can plot the basic statistical data. Then you can develop the regression model or the things. So how regression model is developed is calling the LM model, and then you will be getting all the regression done. You can get the linear regression, neural network, logistic regression, neural network model. So suppose I am doing the training model for logistic regression. I want to form a data frame. I want to form a combined iris train data, and here it is sepal length, sepal width, petal width. So all these datas are the input, and this is the output, and we combinedly called it as train data. So this is train data which is available for us. So we can train it for our classifier. Simply we can use neural network also. The same steps are there. First, prepare the training data and train the model, use it for the predictor. So when we developed, I showed you this model of the neural network, and I also showed you the prediction outcome result. So it is done for all the systems. Whatever the prediction I have done at that time, k nearest neighbor, whichever model has the best accuracy, take that model and evaluate, take that model and use it. So this way we can use, I'm showing all the naive Bayes and all those things. You can judge the accuracy of the system by ROCR curve, then specificity, recall, precision, and all the statistical terms, and then you can plot it. So I'm not talking about clustering today, so because clustering is a different domain. But if you want to see, we can see this thing, clustering also. So I have to come down 1 minute. So from this slide, clustering is another problem, another domain which comes in machine learning, to segment where we do not know the output. We are knowing it is setosa, it is virginica, it is versicolor, but sometimes we do not know. We only know, we have to segment by seeing the like relations between the persons. Like we have African persons, American persons, and the European, but we don't know their names. So on the relationship, on the values, we cluster the data. So clustering can be done by k-mean clustering. So all the grouping of the data can be done on the basis of distance, how closely these individual patterns are related. So we apply k-mean clustering and hierarchical clustering, which and the fuzzy c-mean clustering, which can also be done with R language. So all these types of clustering can be done, and these are the things which I have shown. So coming back, thank you for on the R thing. I have covered most of the part of the data analysis and also the model development. I hope that you have an idea that how R can be used for research in your PhD works. This is an important part. So, yes, sir. I am transferring to you now.
Thank you, sir. I'm thankful to you for giving valuable time and sharing your knowledge regarding research methodology, tools, and techniques. Now, I would like to invite our HOD, Department of Computer Science and Engineering, Professor Mukesh Kumar, for the few words. Sir, please.
Hello.
Yes, sir.
Rakesh sir.
Yes, sir. Yes.
Thank you, Rakesh sir. Thank you so much, Aisect sir, for giving hands-on practice on R language. R is definitely very popular programming language for the statistical modeling analysis, and it is bit easy to implement machine learning, deep learning algorithm also, as you shown in the lecture. Thank you all. for today's session. Tomorrow we will meet for the second session at the same time. Thank you.
One more, if you can on your webcam, we will take a pic for our memories
Yeah.
of this wonderful workshop.
Ashish, sir.
All the
Actually,
participants are requested to turn on their
I am not
on their
having
camera.
webcam right
Rakesh,
now.
sir.
Yes, sir.
Okay. Ashish, sir is not. Okay.
So you can take your slides. Huh?
Yeah, sir. Please, that is the close your sharing, sir. Please. I think so.
Okay, just I will be sharing.